Hi, in today's lesson, we're going to learn about scatterplots. So first you'll see at the top we have a box, a vocabulary box, and then we have a paragraph with some blanks. So we're going to fill this in together. So it says a blank is a graph that shows the relationship between two sets of blank data. So we're talking about scatterplots. So a scatterplot, so let's write that in. Oops. A scatterplot is a graph that shows the relationship between two sets of bivariate data. Okay, bivariate means two variables. Remember the prefix bi, bi means two. All right, it says the data is graphed on a coordinate plane. A scatterplot can be used to determine if an association exists between the two variables. The general shape of all the points in a scatterplot can describe the association. To determine the type of association, look at the points on a scatterplot to see if they are grouped closely together. If they are grouped together, this represents blank. So if they are grouped together, this represents clustering. Whoops. So we're going to put that clustering. All right, I'm going to mark that word out. If all the points are clustered in a line, then the scatter plot shows a linear relationship. So if all the points kind of cluster together to pretty much make a line, we say that is linear, making a linear relationship. If the points are not clustered in a line, then the scatter plot shows a non-linear relationship. If there is an blank, one data point that is far away from all the others, you do not need to consider it when looking for an association. So if there is an outlier, okay, so then we still have the words trend, positive association, negative association, and no association. But if you'll look here, we have examples of positive, negative, and no association. So let's look at the one that says positive association. Positive association, it means that as x increases, so does y. And notice that the points are clustered kind of in a line, and you could kind of draw in a trend line, which is what I've drawn there, which kind of follows the points. This line that I've drawn in would have a positive slope, so that's one way you can notice that it's a positive association. For negative association, it says as x increases, y decreases. So as one thing goes up, the other thing goes down. Okay? And then positive association, as one thing increases, so does the other. And then with the negative association, we could draw in a trend line, which would look like this, which would have a negative slope. No association means the points don't show any discernible pattern. You can't draw in a trend line for this one like you could for the other two because the points are basically all over the place. Okay, then the next part we have the example of whether we have a linear or nonlinear relationship. So linear means they cluster together and basically make a line. So with the linear, I could draw in a line for this. The data kind of follow a line, not exactly, but the nonlinear relationship, look at that. That's kind of more curved, okay? So I will also tell you that linear relationships will either have positive or negative associations, okay? Nonlinear relationships, we'd always say no association for those. Okay, let's go to the next page. Here are some examples. So we're just going to identify associations and relationships. So two things we've got to do. We have to state whether the data shows positive, negative, or no association, and then state whether the data shows linear or nonlinear relationship. So pause the video right now and do example 1. Hopefully you did well with example 1. So the very first scatter plot, you should have said it was a negative and linear association. The second one, we would say has no association and is nonlinear. And then the last one has a positive association and is linear. All right, let's look at example 2. This time we're going to identify the association as positive, negative, or no association, but this time it's with words, with scenarios. So A says the monthly rainfall and the depth of water in a reservoir. So when I think about these two types of, these types of scenarios, I try to think which one is increasing, decreasing, that sort of thing. So for example, I'm comparing the monthly rainfall. So as rainfall increases, so I'm going to put a little arrow up here. As we have more rainfall, what is going to happen to the depth of water in a reservoir? Now, some kids aren't sure what a reservoir is. A reservoir is an area where you collect rainwater. That's just what it is. So as the rainfall increases, what's going to happen to the depth? Is it going to get deeper? The depth is going to increase, or is it going to be less deep? Well, obviously, it's going to get deeper, okay? And I always like to use my thumbs. As one thing increases, so does the other, right? So the depth of the water would also increase. And we know from the first page, it says positive association is as one variable increases, so does the other. So this would represent a positive association. So let's write that down. All right, let's look at part B. The number of pets a person owns and the number of books that person reads a year. Okay, so number of pets a person owns. So the more pets you own, more pets you own, what happens to the number of books you read? The number of books that a person reads. Does that increase? Does that decrease? Or is there any effect? I don't think there's really any effect on that. You wouldn't expect there to be an effect. So we would expect this to be no association. And then C, the number of empty seats in a classroom, okay, and the number of students seated, okay? So the more empty seats there are there more empty seats, are there more students in the classroom, less students in the classroom, or no effect? So the more empty seats you have, the less students you have seated. So this time, my thumbs were in opposite directions. That's represented by a negative association. Okay? All right, let's look now to example 3. And actually, I want you to try example 3 right now on your own. So read through the information and then try it. So pause the video and do example 3 now. Okay, guys, hopefully you did okay with this one. So graph A would be the best representation for this scenario. You could easily eliminate graph C. And the reason we can eliminate graph C is it's showing the temperature of the oven increasing after the pie is taken out. Well, once the pie is taken out of the oven, you're going to turn the oven off, which means the temperature is not going to increase. So C is definitely out. For B, this one isn't going to work because you can see the temperature of the oven is starting to decrease before time is at 0, right? And time 0 is when you're going to be taking the oven out. Unless you're planning on turning the oven off before you take the pie out of the oven, then this one doesn't make any sense. So A is the best answer here, graph A. All right, let's go to the next page. So in example 4, you'll notice that we're going to make a scatter plot and answer some questions. So let's look at this. It says the data below represents the relationship between study time and test scores on the last math test. Create a scatter plot for the following data. So we have study time measured in minutes, and they want that on the x-axis. Test scores will be measured in test scores will be on the y-axis. So let's look at the study times. I see 30, 20, 60, 90, 45, 10, 30, 75, 120, and 80. So I see it goes from 120 is the highest. Looks like 10 is the smallest. And this needs to be on the x-axis. So I'm going to come over here on the x-axis. I'm going to write study time down here. And I'm going to put MIN for minutes. And I need to label this. So I know I need to go all the way up to 120. Obviously, I can't count by ones. Do I have enough to count by tens? So let's see. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120. So I definitely could count by tens. I can probably get away with counting by fives. So let's do that. So I'm going to let each line represent 5. And you need to be doing this as well. Oops. And if I'm going too fast, then you can always pause the video while you catch up. Oop, I've got 105. I'm going to add a few. 110, 115. There we go, 120. I've just added a few there. Okay, so there's my study time. For my test scores, it looks like my lowest test score looks like is a 62, and the highest is a 97. So the test scores, you're thinking about grades from 0 to 100, and so I can probably just count by fives here all the way to 100. Okay, and I'm going to label that side test scores. All right, and now I just need to plot that data. So first I see a study time of 30 minutes resulted in a score of 87. So I'm going to find 30 on the x-axis, and I'm going to go up until I see, I'm going to show you how I'm doing this. So there's the 30, and I'm going to follow this line until I get to the 87. So that should be somewhere between the 85 and the 90. Okay, so I'm going to get, that'll be right about there. Okay. All right, the next one, I'm going to put a little check here so I know I did that, is 2074. Would be about here. 6092 is going to be about there. And these aren't going to be 100% exact. You just do the best you can. So 9097 would be about there. Make your dots big enough so we can see them. 4585. Let's see, 1062. 3083. Oh, I had a 3087. Oh, there we go. 3083 right there. 7590. 9500. I'm sorry, 12095. Just going to be all the way. Whoops, didn't mean to slide that. Right about there. And 8091. Okay, so there's my scatter plot. All right, so then it says, does the scatter plot represent a clustering of the data points? So a clustering would be, are they clustered together? Could you kind of make a line? And the answer here is yes. Okay. The next question, is there a linear or nonlinear relationship? Well, this is going to be linear. So if you said linear relationship, then there is a clustering, period. What type of association does this scatter plot show and explain? Well, since it's linear, it definitely has some type of association, either positive or negative. If it was nonlinear, then we would go with no association. Okay, but it definitely is linear, so our association, this is kind of trending positive, right? So if I was to draw a line, it kind of goes in a line like this, and that line would have a positive slope. So we would say positive association. And what does that mean? Well, a positive association means that as one thing increases, so does the other. As X increases, Y also increases. Well, the X was study time. So we'd say as study time increases, the Y-axis was test scores. So as study time increases, test scores increase. Okay? And then, are there any outliers in the data, and if so, name them. So an outlier would be a data point that's kind of not in line with the rest. And I would say, yeah, there is an outlier. This one right here is an outlier. Okay, and so that is the data point 120.95. Okay, so we're going to come over here. We're going to say yes, 120.95. The person that studied for 120 minutes got a 95. Okay, so that is actually it for your intro to scatterplots. So now you're going to go ahead, submit this, and then work on the independent practice. Good luck.